In this video, the learner will use tangents of circles to solve problems. First, let's remember what a tangent is. A tangent is a line that intersects a circle at exactly one point, called the point of tangency. So we have this tangent ray right here. Ray xy is tangent to the circle at the point of tangency, point x. Line ST is tangent to the circle at its point of tangency, which is point S. Our first theorem to do with tangents is a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So in this picture here, line L is tangent to circle S if and only if ST and L are perpendicular. So we can see we have that right angle, therefore line L is a tangent. Again, we have a radius drawn here. We have that right angle and this line that would be a tangent to that circle because we have that right angle. This theorem is going to be very useful because we could use right triangles to then solve some problems. So first we're going to determine if the segment KL is tangent to circle J. Well, if KL is tangent to the circle, it must mean it's perpendicular to the radius JL. So we need to determine whether the triangle JKL is a right triangle. We can test that using Pythagorean theorem. I have 8 as one of the legs, 15 as the other leg, and then this whole hypotenuse is 9 plus 8 for the radius here. So using Pythagorean theorem, we'll have 8 squared plus 15 squared, and we're seeing whether or not it's equal to 8 plus 9 squared. That hypotenuse is 8 plus 9. So 8 squared is 64, plus 15 squared, which is 225, and we get 289. 8 plus 9 is 17, and 17 squared is 289. Because they're equal, we know that this has to be a right triangle. Okay, we have this problem down here. Determine whether GH is tangent to circle F. Okay, here's some examples. JH is tangent to circle G at J. Find the value of X. We know because JH is tangent to the circle at this point of tangency J that this triangle is a right triangle. So we have the leg of X, the leg of 12, and then the hypotenuse, which is X plus 8. So we could redraw that right triangle to look like this triangle GJH here. Now we need to use Pythagorean theorem to solve for X. So I'll have GJ squared plus JH squared equals GH squared. So X squared plus 12 squared equals X plus 8 squared. X plus 8 squared is really X plus 8 times X plus 8, so you have to FOIL that out to get X squared plus 16X plus 64. You're going to subtract X squared and subtract 64 from both sides to get 80 equals 16X, then divide to get X equal to 5. Then we've determined that the radius of that circle is 5. Okay, you're going to use this same concept here to solve for X in each one of these. The next theorem is if two segments are tangent to a circle from the same exterior point, then the segments are congruent. So in this picture here, both of the segments AB and CB originate from this point B outside the circle. Therefore, those two segments are congruent. So the measure of AB is going to be congruent to the measure of BC. Another one to illustrate this point, we have point A, exterior to the circle, and both of these segments are tangent to that circle. Therefore, AB is congruent to AC. In our example problem here, AB and CB are both tangent to the circle D, and we want to find the value of x. In this picture here, we know both of those segments, AB and CB, originate from that point B. And since they're both tangent to the circle, we know that those segments have to be congruent. So therefore, they have equal measure. So we know x plus 15 has to be equal to 2x minus 5. Subtract x and add 5 to both sides, and we get x equals 20. I want you to go ahead and do parts B and C to this problem.